Hello, we're back again. Still with Learning Guide 5. We're on part 5 now. And we're on topic 2, example 1. All right, so we want to identify characteristics of quadratic functions in standard form. All right, so these are some of the characteristics that we're going to look at. So we'll go through them. So the first thing is we want to know direction opening, and we know that by looking at the A. If the A is positive, it opens up. If it's negative, it opens down. The chord and the vertex, which we've done, that's your P and your Q. And maximum and minimum, well, that's tied in with your opening up and opening down. So if we had an opening up parabola, we would say it has a minimum, because the maximum would be infinity because it keeps going up, these arrows. If we had one opening downwards, these arrows are going down forever, so this has a maximum. Okay, so that's how you can tell maximum, minimum. The axis of symmetry, we know that, we've done that. The x and y intercepts, we can find those. And the domain and range we've done. So here's the first example, which we call a basic parabola. And we know it opens up. We know the vertex. We know the minimum value. Okay, it's asking us for the minimum value. And I know it's a minimum because it's opening up. So the minimum value is 0, because that's your Q. And it's at your P. All right, so there's your minimum value there. The axis of symmetry, okay, the intercepts, and then the domain, range. This stuff you don't need to do. It's fine just to say D equals XER. That's acceptable. This is just a little fancier way of doing it. Same thing down here. This is fancy. You can just say the range is everything greater than 0. Okay, the second example here, there's our sketch. It's opening up. The vertex, it's minimum because it's opening up, and remember it's your P and your Q. So that's important that you get this vertex using your Desmos on your calculator. All right. It's that, the axis of symmetry, so on. And C, the same thing. Again, make sure you use your Desmos to put that in, to get that picture, and then you can get all these answers. All right. Okay, so you can pause it, and you can try these two and check with me. So make sure you put the zeros when you're doing the x-intercepts, important, because that tells me it's an x-intercept -1, 0, -5, 0. And how you can tell the y-intercept really easy, you just look at the constant, the one that has no letter attached. And remember, that's going to be 0, 5. Domain, x, ER, range, y is greater because it's going upwards to -4. And some people ask me, is it domain always going to be XER? When you just have functions, yes, but when we have real life problems, no. And we're going to see that pretty soon now. It's less than because it's going downwards. All right, now we're going to go on to word problems, real life situations. Okay, so we have this frog, all right, and the frog is jumping in a pond, and this is the modeled function of the frog. So really, really important, when you're given this function, put it into your Desmos. All right, remember you're going to use y instead of that. And it's going to give you a picture, so we'll use this picture down here. Okay, so we'll use this picture. Now, super, super important, once you put it into Desmos, you want to get the key characteristics labeled. Key, okay, and label your sketch. Okay, so this is key, it's a y-intercept, this is key, it's a vertex, and this is key. So when we're looking at that, we're looking for y-intercepts, x-intercepts, and vertex. So you want to get those labeled. Okay, so again, with the Desmos, you just have to put it in and then touch the little dots at those points, and the answer will appear. All right, so with this one, it's 0, 25. The vertex is 0.15, comma 36.48, and this guy is 0.43. Oops. 0.43, comma 0. Okay, so those will give you the answer to almost all questions initially. Okay, so the question's asking us, A is to sketch the function, so there it is. B is asking us to find the y-intercept, so there it is. And what does it represent? Well, it represents where the frog starts its jump, okay? And the next question says, what's the maximum height? So remember, we had the vertex of 0.15, comma 36.48. Well, that's the maximum height it gets to. And I just rounded it to that. And it took roughly 2 seconds to get to that height. All right. So that's the answer to when does it reach it. So roughly 0.2 seconds, and what the height is, it's roughly 36.5. When does the frog hit the water? Say that's going to be this guy. And remember, this must be like on a lily pad, and the frog jumped. And here's the water. So it hits the water right there. So that was 0.43, comma 0, that key characteristic. Remember, your x-axis is your time, because if you look at t in your equation, t and x were just interchanged with each other. And so I had a little boo-boo here. This is not 0.2 seconds. The answer is 0.43 seconds. Okay, what are the domain and the range of the situation? Now this is important. You don't say D is XER, because that would mean the frog can be in the air for infinity amount of time. So no. You now look at the frog starts at 0 and it goes to 0.43 seconds. So that's your domain. And then you take your vertex, it starts at 0 and it goes up to that 36.5. 0.5. So that's your range. All right, so now you are going to, oh, there's one more question here. How high is the frog after 25 seconds? So again, you can use your Desmos. All right, you can use Desmos. And when you're using Desmos here, you're going to make x equals 0.25. And what you're going to see on your phone is you'll see the parabola, and then you'll see a line going up. This line is the x equals 0.25, and you just find that intersect. Or algebraically, you can just plug it in, and you can get the answer. So either way. All right, so you can pause and you can try the example of the diver jumping off a springboard. So the first thing you always want to do is do a sketch. So I'll make this my x and y axis. But remember, this is t now, right? Because we're using t instead of x. And this is h of t, the height. So just switching x's and y's up. So when I put it into my Desmos, I got this function. I'll just do a little sketch. Okay, remember it's just a sketch. Now, like I said earlier, you must tell me all these key characteristics. So again, Desmos will tell you that by just touching the little dots. And this is 1.74, 0. Okay, now once you got your key characteristics and you sketched your graph, now you can answer the questions. What does the y-intercept represent? The height, the diver was at initially. All right, and if you want to say what was the height, you would say 3 meters. But it told you in the question, it's a 3 meter dive board. Okay, what is her maximum height? Well, she's in the air and she gets to, remember, this is your time, this is your height. So it's 5.36 meters at 0.69 seconds. That's when she reached that maximum height. How long was she in the air, or how long was she in before she hit the water? Well, she hit the water right here, because remember, this is the water, this is sort of the diving board, right? This is her standing. So we know 1.74 seconds is when she hit the water. The domain and range, remember, your domain starts at 0 and it goes to that guy. So it's between, that's our between symbol. And the range is again that between symbol, 0. And the height she maximum gets to is that. And what is the height of the diver? 0.6 seconds. So that you would put into your Desmos, and out comes 5.32 meters.